Welcome back to Summarize Science. Today, we're exploring a mind-bending question. How do AI models actually remember facts? We often think of it like a giant set of flashcards, just memorizing that Paris is the capital of France. But a new paper suggests it's much, much deeper than that, revealing that deep sequence models tend to memorize geometrically, even though it's unclear why. Researchers contrast two ideas of how AI memory works. The first is associative memory, which is that flashcard system shown on the left. If you train it on A connects to B, it only knows that specific link. The second, more powerful idea is geometric memory, shown on the right, which is like building an internal map. On a map, you can see the relationship between all the concepts at once, even ones with no direct connection. To test this, the researchers created a special task involving a giant, star-shaped graph with thousands of paths. The AI was first taught all the individual connections, like corridor 1 connects to corridor 2. Then it was given a final destination and had to figure out the entire path back to the start, a multi-step reasoning problem. This is incredibly difficult if you're only using the flashcard method, as you'd have to trace your way back one step at a time. Against expectations, the model succeeded with near-perfect accuracy on this in-weights task, where the graph is memorized. It could solve these complex paths even for routes it hadn't been explicitly trained to find. This sharply contrasts with the model's failure on a similar in-context task, shown here, where the graph is provided in the prompt. This success strongly suggests it wasn't just looking up individual connections in its memory. Instead, it must have built a comprehensive map of the entire graph in its mind. So how do we know it built a map? Researchers visualized the AI's internal representations of all the nodes in the graph. These heat maps show the distance between concepts inside the AI. The bright diagonal line means that the starting and ending points of a specific path are seen as close to each other. It's the digital equivalent of seeing that Los Angeles and San Francisco are close on a map of the United States, but far from New York. This structure emerged even when the model was only trained on local edge connections. The most fascinating part is why this happens. The researchers argue that it's not because the map is a more compact way to store the information. Sometimes it isn't, as their analysis on page 13 shows. They rule out other obvious pressures, like the way it was supervised or architectural constraints. Instead, they suggest it's a natural bias in the learning process itself, which they connect to a spectral bias. The AI seems to have a built-in preference for creating these elegant, structured geometric maps from simple, local data. This geometry arises naturally, even without the learning pressures typically thought to cause it. So to recap, this research shows that deep AI models tend to learn by creating geometric maps of information, not just by memorizing flashcard-like associations. They build an understanding of global relationships even when only trained on local ones. This is a fundamental shift in how we might think about AI memory and knowledge. This could lead to new ways to teach AI, to make them better at reasoning, and even to help us understand how to make them unlearn incorrect information. Essentially, AI might be understanding the world in a much more connected and structured way than we've been giving it credit for. What do you think this hidden geometry means for the future of AI? Let us know in the comments below, and thanks for watching Summarize Science.